All right, hello, conceptual physics. Um, Today we're going to be talking about one of the more famous equations in physics, E is equal to mc squared. If you've done your homework or your work for Tuesday, you'll know that E is equal to mc squared is actually a formula used in order to find the amount of mass provided to an object by the energy of that object. All objects have energy, whether it's potential or kinetic or what have you, and that energy does, in fact, add mass to it. But the most common use for E is equal to mc squared that I've seen is for particle accelerators. So I really want to focus on particle accelerators for a day. All right, so for starters, just a quick refresher, right? E stands for energy. M stands for mass. And c is for the speed of light. All right. So the video I showed you guys said that when Einstein initially set up this equation, he set it up as m's equal to E over c squared, right? And the reason why he put it in that form is that the energy provided by the object, right? The energy of the object, if it's a ticking watch, if it's a running human, the fact that they have different types of energies acting in their bodies, not just the matter, but different energies, that energy ends up actually providing mass, and it provides mass by E divided by c squared. Now, the most common question I always get is, Mr. Burkhart, what is the speed of light doing in here? And the best explanation I have for that is it be that way. I don't have a great explanation, and physicists really don't either. It's just one of those little weird, little quirky parts of nature where it worked out that way. And I'm sure there are some particle physics out there yet to be discovered as a solid explanation for why that happens. But we haven't quite gotten there yet, and we don't have a great way to answer that yet. So there you go. Still some mysteries in physics. Anyway, what I wanted to focus on in here is when we're using this equation, something that we want to do in a particle accelerator is obviously we want to accelerate tiny little particles, right? We want to accelerate them and make them go faster and faster and faster. And in many cases, we want to get them to smash into each other. So one thing that we actually do is by making them go faster, we increase their kinetic energy. Right. So as that energy goes up, what happens to the particle? Well, the particle goes from being a tiny particle to a larger particle. And if you get the particles to be large enough, when they smash into each other, it's a lot easier to see the parts that make them up. It's easier to see the energies that they release, and it's just it's a cool little proof that E is equal to mc squared does in fact work. All right, now what I have planned for today is you guys have a little video to watch on particle colliders and how particle colliders are used, and I just wanted to share this with you guys so that you had some backdrop into why I'm talking about particle colliders today. Make sure you answer the questions that go along with the video, and talk to you again soon. Bye-bye.